Thank you for having me. My name is Adam Schaal. Today I'll be talking about automating vulnerability management from scratch. Quick about me. I'm a principal application security researcher for Contrast Security. There's my Twitter and handle and my website if you'd like to follow along with my work. I'll have updates regarding today's topic that I'll be posting at some point too. Hobby-wise, I enjoy spending time with my family, doing some home automation. I'm a KernelCon board member, which is a conference in Omaha, Nebraska, and I enjoy participating in CTFs. I have an extensive background in both development and application security, so I'm familiar with breaking and making applications. Today we'll be talking, like I said, about automating vulnerability management. We're going to discuss how I was brought into a corporate environment to build up their vulnerability management program from scratch. And then I've already open sourced some of what we're going to be discussing today. There's a few things I still need to clean up, remove corporate remnants from, and I will eventually post those online and drop that in my Git repos. So. I suspect that if you're in this call, you probably know what vulnerability management is. Clint went ahead and discussed it in the talk before this. Thanks for the lead-in, Clint. But if not, if you're new to the process, let me just describe it real quick. It's a cyclical process of collecting, identifying, classifying, prioritizing, remediating, and mitigating vulnerabilities found within your company environments. Wow, that's a mouthful, and it sounds like a lot, but it is. It's a circular process. It never ends. Usually it encompasses security operations, networking, all the software that you have installed in your environments, and all the software that you distribute. What vulnerability management is not, it's not intended to replace good security practices, and it's not the best prevention method for avoiding vulnerabilities. There's there's people out there who think that, hey, this is good enough, and what I'm here to tell you is that it's not, but it does help quite a bit. So with that said, let's talk about what we'd like to focus today. The goal is to learn each step in building the program, and we're going to start discussing how I accomplished this feat at a large employer in the cable services industry. So when I was hired, it was a large company. It had 3,000 employees, over 900 developers, millions and millions of lines of code. It was a multinational company, so we had developers in lots of different time zones. There was always mergers and acquisitions going on where we were inheriting terrible, bad code. There was dozens of programming languages and diverse environments, multiple desktop environments and multiple server environments, and this all existed already when I joined the team. And there was a need to also, we were a big company, we processed payments. And so there was a need to also be PCI certified. So the PCI 6.1 requirement says that you need to ensure all system components and software are protected from known vulnerabilities by having the latest vendor-supplied security patches installed. This is the critical line here, deploy critical patches within a month of release. So as you can imagine, this presented quite a challenge. It was a lot to try to get everything done within. It was a lot to try to get everything done within the month time frame if you had a critical release, especially if you had something that was on a team that you were unfamiliar with, or the code was just so awful but it was so big that you couldn't update fully. So they told me, good news though, we already have an existing program. But with good news, there's bad news. The existing program wasn't great. This is the security operations program that existed when I arrived. If you are in the vulnerability management space, you might be aware of the CISA, the Cybersecurity Infrastructure Security Agency, vulnerability bulletins. I was doing this in 2018, not when I took this screenshot. And let me tell you quickly how this worked. First, every Monday, sometimes Tuesday, occasionally a Wednesday, and possibly never, they would come out with a weekly bulletin. And if you sense inconsistency, you're right. In 2018, these bulletins were few and far between. They were very difficult to get on a weekly basis. Or oftentimes we would go weeks without seeing one. I remember a particular stretch between Thanksgiving and Christmas where we didn't, or it was New Year's, where we didn't get a single bulletin. And then on New Year's Day, we received, it was like 8 at once. So that was kind of a lot of work and a lot of backfill that we had to work from. So the bulletin would come out, and then there was a woman in Atlanta who would furiously type. She would go to the webpage and she would retype it all or copy and paste into Microsoft Excel and color code and organize furiously, because she would do it on a Monday. And if there was no bulletin, she didn't have to do it. But if there was, she would try to get it all done. And then by Tuesday, we would meet up and have an hour-long phone call. And everyone would join in this phone call. The desktop guy would usually say, I'm going to wait for Patch Tuesday, which is Microsoft's weekly patch. And generally speaking, a lot of people only really responded to anything critical. So didn't have a lot of follow through. There was no tickets created. Everything was hand wavy. And we just had to trust that everyone was doing their jobs, which you'd like to do, but can be difficult. So there was a lot of existing issues. They only had a single source of vulnerability inputs. So when it was inconsistent, like I discussed, we weren't evaluating anything new. We had an incomplete picture. There was no guarantee that every stakeholder showed up. There was no guarantee that it was accurate. We had no follow through, like I discussed. Compliance wasn't involved at all. So how can we verify that this risk has been mitigated? I mean, that's part of the audit trail that we had to do for PCI. Additionally, it had significant overhead. It had a lot of unnecessary work between phone calls and somebody spending all day copying and pasting into Microsoft Excel. So it was, overall, there was a lot of issues with this existing program. So I thought, okay, what would an ideal vulnerability management program look like? First, we'd have to have multiple sources to import vulnerabilities from. Ideally, we're getting as much data as possible. We also want a whole picture, right? We want to complete an asset inventory. We want to look at what we have on the network side of things, desktop, installed software applications, and any distributed software. We also wanted to involve compliance. We needed a compliance department to be involved. We wanted them to own the enforcement process so that the application security team, which I was on, could stay removed from enforcement. We just inform compliance. You do all the work of tracking down these people and making sure that they're getting stuff done in a timely manner. And ideally, we can automate that process a little bit. Also, we wanted to reduce overhead. No Excel spreadsheets, no hour-long phone calls. The hardest workers in this process should be Python and Jenkins, or whatever you want to use to do your own automation. After I thought about what an ideal vulnerability management situation looked like, I thought, challenge accepted. I'm going to do that. I'm going to take, additionally, I'm going to actually roll the operations existing process into my process, and I'm going to make their process better while creating the application security VM. So this was my course correction plan. I'm going to stay on this slide for a minute here. First, I wanted to automate asset management. We needed a holistic picture of our assets. Many times developers who are working on the same code for months and months and months, they don't even know every library they're using. I mean, how many times, have you joined a team and fully analyzed every single thing that they utilize? I mean, no developer really gets time for that. The developer gets hired, it's told about the business processes, gets their computer environment set up, and gets tickets, like start producing. So that's a problem. This process is even more important if you work at a large company that purchases other companies. You're inheriting their tech debt and you're inheriting their bad code. And especially if you buy a company and that software gets moved under a different team. That's additionally another concern. So if we can determine a way to collect all the information about our assets, hopefully we can match them to vulnerabilities. Speaking of vulnerabilities, we want to collect as many as possible. As I said, we would like to do it daily. So not on a weekly basis, like just constantly be updating our amount of vulnerabilities. If we can make this a process that's happening at near real time, then we also don't have to worry about having these big weekly meetings, especially if it's significant week. We're handing out a lot of work, which can be, it kind of hurts the relationships between the application security teams and your development teams. Also, it's important to see any changes in CVEs, whether it be like new descriptions, new scoring, right? If something changes the way a CVE was first posted and the scoring increases to a critical, I can no longer wait by PCI standards. I can no longer wait like 90 days to fix that. I'm supposed to fix it within 30 days. I would like to match the new vulnerabilities with the current assets. So I would like to do it with all current vulnerabilities and current assets as well. But then I'm not going to focus on like the history, but that's obvious first move is check all your assets versus like all the vulnerabilities that have ever existed. But then from then on, just match all your current assets with the new vulnerabilities as they come in. I'd like to automate the compliance oversight, maybe create a method for automatically ranking vulnerabilities by criticality. Clint, like I said, he discussed vulnerability classes that you could group them into. I'll discuss similar ideas. Highly critical tickets will have a 30-day fix window. Again, everything else, could have a longer window. I dictated 90 days at the time. And then during a time frame which the ticket is open, feasibly I could create like steps for compliance, as in auto emails and escalations as necessary. And then lastly, I'd like to automate remediation closures. If a version gets updated in the asset management system to something that is not vulnerable, I'd like to potentially close a ticket. So an example would be if one library of jQuery was vulnerable to a cross-site scripting attack, and then the development team upgraded that library to a version that was not vulnerable, I should be able to tell that the vulnerable version no longer exists within our asset and automatically close the ticket that we've opened. That's a lot, but we're going to try to cover it, speed through this. So step one is asset management. This is the most important part of vulnerability management, in my opinion. You need to know what you even have, right? There's in these large environments, a lot of times it's difficult to know what you have available, what kind of assets you really have. And it can be endless. I mean, the amount of things that you can track here, can grow and grow and grow. It could be laptops. What kind of laptops have you handed out? It could be application code that you're shipping, enterprise applications that you're serving, like on a website. It could be servers, virtual machines, infrastructure. Are you hosting open source software? All kinds of things can come in as an asset. You can consider them assets. So how was I going to track all of that? Luckily, I worked for a company that knew the importance of asset management. I didn't create this program, but I probably used it to its fullest potential. And I even convinced them to open source it. At the time, there was a tool there that was mostly meant for the IT team called Asset Compliance Tracker. And this covered basically all servers and virtual machines. If you notice this underline on my slide here, this is actually hyperlinked. If you'd like to look at it, it's open source. At the end of the talk, I'll also give you the fully qualified URL, and you can copy that down. I'll make these slides available after this talk as well for anyone interested. This is called the Asset Compliance Tracker, or ACT for short. It's essentially a PCI monitoring solution for VMs and physical servers. So this was meant to be like a PCI tool, but I was able to utilize it to do a lot of vulnerability management as well. Basically, each server had a chef compliance spec on it, one for Windows and one for Linux clients. And then each chef compliance spec went and grabbed the following information. It grabbed the operating system name and version, which ports were open, which software was installed on that server. As you can imagine, this is super useful information to have, and it's a big piece of the puzzle for vulnerability management. So I have all that information available. So where do I keep it? Well, this is where I took this information, this data, and I sent it into a web page built on Docker using AWS Fargate. So the data is displayed in a web page, and it's completely sortable and editable. You might ask yourself, why does it matter that we're displaying it in a web page? Can't we just grab the data using the same calls that it's using? This is how it was already set up. So I thought, okay, I can use this data. And again, this is a one-stop shop for asset compliance. I'm going to touch on PCI here. I know that not everybody in the call is interested in that, but we had different segments. We segmented our servers and our assets based on different classes, A, B, and C. A was the most secure data because it touched PCI data. And B was more secure. It doesn't touch PCI data directly, but it interacts with A nodes. And then C, it doesn't either touch it or interact with A nodes. So that is the server and virtual machines. And why stop here at servers and virtual machines? We can include desktops, laptops, and phones as well. After all, IT has already they've already tracked all that information into this ACT before giving them out to new employees. So I have management software already installed on the machines, so I can take this information and I can grab it all. So I'm grabbing servers, I'm grabbing desktops, phones, laptops, and I'm grabbing all of that data and I'm storing it. So it's ACT is gonna come back into this scope later, and this tool is open source. I highly recommend you go check it out if you're, looking to do this all open source. There are tools that do asset management as well. I'm not going to, I think that you could purchase something as well, but we didn't have the budget, as a lot of security professionals will tell you. We didn't have the budget to do this. So this is a homegrown tooling system. So again, this is a lot of the physical assets. We still need to figure out our own software. What tools and libraries are we using? Are we bringing in open source software? What does our infrastructure look like? What tools are we using on the network? Do we have anything in operations that we need to consider? This was where we had a little bit of a budget. And scanning your own software is probably best with a tool. You're not scanning for vulnerabilities here. This is all about asset collection right now. I work for a company that does this, so I'm not gonna, promote any particular company. There's plenty of fish in the sea. But the point of this is, like, the best way to go about scanning your own software is probably just using a tool. But what I want you to take away from this side is, what features you want here, because you want to know, does it detect open source software? How much detail are you provided? Does it detect standard libraries? Does it cover all the code bases your company uses? Does it detect changes in software? Remember that example I mentioned earlier about jQuery? If I change the software, does it delete it from its asset inventory? And you're going to have similar questions for your infrastructure scanning tools. Does this tool scope outside our network filters? Is operations confident that this tool is capturing the full picture of their assets? If you can answer these questions, then you can move on from the software asset management portion. So we've covered servers, virtual machines, desktop, laptops, phone assets, software, both internal and stuff that we ship to clients, and infrastructure. This was all done, again, at the company I worked at. We did all of this and we tracked it. We took ACT information, and we had Chef feeding it and IT feeding it information. And then we had some of our custom tooling, which I just talked about. And we actually automated it. We needed to create automation. So we started using Jenkins. Jenkins is an open source automation server, which ran some Python scripts that I created. And we stored all of the data into a MySQL server. Obviously, a lot of this process is pretty sensitive and proprietary, but I'm confident that a lot of security professionals could do this themselves, create their own script to save it to a SQL server. A lot of this work was actually setting up like the data framework and how I wanted it to look overall. So yeah, with my code release, I'll be using Python to create schemas for typical ACT results. These schemas will take and generate fake data. So I'll do that in Mongo. I know Mongo is not everyone's favorite, but it's the easiest way to do it. Okay, so that's automating asset management. Next, I'm going to talk about automating vulnerability management. So the weekly bulletins, they don't work as a good source of truth. They're inconsistent. The cadence isn't quick enough. The adjustments aren't included. If a previous CVE gets a scoring adjustment or an update to the description doesn't come back, it doesn't get re-referenced in the bulletin section. I actually have been told that nowadays it is doing this. So number 2 might not be a valid point anymore. I haven't been keeping up to date on this process as much anymore, but I've been told that number 2 might be fixed. So take that with a grain of salt. And number 3, there's not enough information in those bulletins. There's no version numbers. It's missing a lot of information. If you look at their actual schema, which I'm linked right here, you can get stuff like version numbers from there. So you could have a string that you can actually search on when you look at your assets and determine whether or not your version is within the vulnerable range. So if I look at the NVD JSON feeds, I can pull data directly from using their JSON schema, and they even have a modified .json that gets updated daily. So this is like miles better than the weekly bulletins, which was used in our existing process. And so I'm automating the vulnerability collection. This is a simple Python script which just collects all of it. First, I automate the import of every single file that existed because I want to check my assets against all previous vulnerabilities as well. And then I send that to a database afterwards. So inside of my database now, I have all of my assets and I have all of the vulnerabilities. And then I create a process that gets all the latest vulnerabilities at like 3 a.m., for example, that runs daily as well. So where else can we find vulnerabilities? I talked about how a single source of truth isn't a great place to look for vulnerabilities alone. There are a lot of different places that will post vulnerabilities, and I'm not going to go over all of them, but some of the best places can be GitHub issues. There's GitHub security advisories as well. You could find stuff in your tool outputs, Twitter, blogs, bug bounty write-ups. If you're staying up to date as a security professional, which you should be already because the landscape is ever changing, you will probably have a good handle on where to find more vulnerabilities. So I'm not going to get into automating that part of it. That's something that any professional can probably set up. So let's think about this as I'm automating this vulnerability collection. So I'm automating it from NVD. I'm automating that's the logo for the Git Vuln Finder, which I found to be a pretty good online resource for searching databases for vulnerabilities. Repos for vulnerabilities, and then any tool output. And I'm automating that with Python and saving it into a database, in this case, MongoDB. While I'm automating it, there's some important factors that I want to reference. The vendor, the product, the versions, the description of the vulnerability, the dates, i.e. is it discovered or has it just been modified? Because I can treat those differently. CVE information and criticality if possible. So here's just an example of how you could test criticality. If you wanted to do something like this, if it wasn't detected, you could have kind of a critical list and a blacklist where basically if it says remote, execute, arbitrary, root, something like that within the description, you might flag it as a probable critical. Meanwhile, something in a deny list would be like if it also says XSS, like if it's a cross-site scripting vulnerability and they use the words remote execute, because sometimes people write, I can remotely execute cross-site scripting. That might not be a critical vulnerability. And then this is just an example. I mean, it's all dependent on what your risk appetite is. Once you automate the vulnerability collection, then you have to assess criticality. One way to do that is, these 4 categories which we used. Are our systems affected? Are they internet exposed? What kind of category is it? Is it remote code execution possible? Is this an RCE? Are there public exploits available? That's a big one. If there are enough public exploits where ScriptKitty could go run this if they wanted, that would be something that would concern us. And operational or business impact. Are the affected systems free from any client customer moratoriums? And that would help us determine criticality. So now we've accomplished basically the first 2 steps. Step 3, this is a little more of a thought experiment here. You kind of have to follow along, and I do have some code for this. This is the code that I need to remove a lot of proprietary stuff from before I open source. But you have assets and you have vulnerabilities, and your assets have a vendor and they have a product name and they have versions associated with them. And your vulnerabilities, you're trying to, you have a vendor, a product, and a version, but you also have a description and a potential criticality. Matching is not an exact science. Oftentimes you still have to correct some data in the long run. The more efficient this step is, the less time you have to spend fixing data. As you notice, these three are identical, so you can do some sort of lexical analysis comparison between is most of vendor the same as this one, is most of product the same as this one, and does the version fall within, does this version, excuse me, does the asset version fall within the vulnerable versions? And so if you have this information, you can potentially identify the vulnerabilities that you're susceptible to. There was a little bit of a training period on this, the matching algorithm, and eventually we got it to the point where we were pretty confident that everything that we said was a match was a definite vulnerability in our environment. Then we had a probable category, which got manually reviewed, and then everything else dropped off. So now we've talked about automating asset management, automating vulnerability collection, and matching. So next is the compliance oversight. So now that we have identified vulnerabilities in our code, what do you do? Well, we can automatically create and assign Jira tickets. The ACT database has a place where you can list responsible teams and managers for each entry. And so you can extend the other asset management to include this. Basically, this team developed this software, and therefore they are responsible for it, and this is their manager. And we maintain the managers as well, because if you need to escalate something to meet a compliance deadline, it needs to go up to a manager level. Another example, and that was software, but another example would be the IT owns desktop environments. So if you have Microsoft Word is now vulnerable on all of our desktops, this department is responsible for updating everyone and pushing out new Microsoft Word updates to every desktop, for example. Throughout each sprint cycle, the vulnerabilities that are then assigned out to teams who can include them in the next cycle. Highly critical vulnerabilities are marked to mandate a 30-day fix, and it can be included in the current sprint cycle per discretion of the manager. So again, PCI compliance told us 30 days. So if we have a critical vulnerability, that's something that can be potentially put into the current sprint cycle. And how can we assign kind of like other fixes, like beyond just the 30-day critical fix? We tended to deal with those 4 criticality categories that we discussed, and basically if it had 3 of the 4, we tried to keep it to a 60-day fix. And then anything less than that, we said was a 90-day fix. We often missed 90-day fixes. You know, I wouldn't say often, but we missed them a lot of times, and that's where compliance would have to come in. But if we were mandating a 30-day fix or a 60-day fix, generally we had a lot of processes in place to ensure that happened. The particular at particular junctures, we would have automated emails sent out to the assigned developer, for example, and then the developer's manager. And if we were way behind, it would go to a director level, or a middle manager above that manager. So that's the scoring rubric that we developed. And you can do something similar. That's I'm not pushing that on anybody. That's just how we did it. So next, we would like to automate the remediation closers. So once you have all your moving parts together, you can actually automate the remediations. Again, this is what I discussed near the beginning. If you have a vulnerable library X, if it's vulnerable between these versions, and it disappears, we could have an open ticket status inside of our database, which that's what we did. And if the ticket has an open status, it also has the ticket number. And if it's disappeared, we can actually change it to closed ticket status and go out to the ticket number and close it automatically. So this was something that really made a big difference in developers' lives as well, because they were updating things, and as it got pushed out into production environments, their tickets would automatically disappear from their pipelines, which was another way to maintain that relationship. So here's kind of this is the compliance portion of this. We had a flow chart here, and it might be hard to see on a lot of monitors, but compliance basically, this was how they escalated if they needed to escalate. There was also exception requests that could be done, and those were sent through compliance as well. If a developer needed an exception because it was a breaking change, for example, that went through compliance, and compliance could issue a exception. So this is a little less fancier than my other slides, but it's pulled directly from our Confluence page. So future work. I'm very near the end here. So future work. I'd like to utilize machine learning for matching. I think that it would be cool if you had a pop-up that said, does this vulnerability match the asset, yes or no? And you trained your matching algorithm. The matching part was definitely the trickiest part. Like I said, we still had a lot of manual review. We had a definite bucket where we were definitely vulnerable to these. And then we had a probable bucket. And the probable bucket was a lot bigger than the definite bucket. So I'd like to get it to a point where you could grow that definite bucket and grow the not vulnerable bucket and just start to slowly shrink the amount that you need to manually review. And it'd be really cool if we could train it on the manual review part of things right here with does this vulnerability match the asset, for example. Sources. This is the asset management. Repo. I encourage you to go check it out. Also, my Git repo will have a few things listed under asset management and vulnerability management. I don't think I included that. I did at the end here. This is some of the sources I used for vulnerability collection. I talked about the GitHub vulnerability tool, the Git Vuln Finder, which I thought was I think is really nice. We use the JSON feeds from the National Vulnerability Database, where we were automating, grabbing everything that got modified in the last night, and then we were putting that into our databases. So, yeah, and then there's the Bulletins link if you wanted to check it out. But that's how you can build your own vulnerability management system from scratch using very little outside tooling. Thank you very much.
Thanks, Adam. A little bit of feedback. I don't know if everybody else is, but it might just be me. Yeah, I was just going to check to see if there's any messages. I was very informative. Let's see. Yeah, my biggest question there is like I don't know. So some of the stuff that you were seeing from a vulnerability management perspective, right? You're really going a lot at the network side of things. I guess that the app plays into it quite a bit as well, right? But you're feeding, like most of the feeds that you had that you just barely called out were very much like, CVE focused. So have you seen much of a distinction between the number of vulnerabilities that are coming out of the app space versus the network space, or is it all just pretty mixed?
We saw we were a Microsoft heavy environment. So we saw a lot of Microsoft vulnerabilities more than anything. Which is why the security operations setup was built in front of the application, the security side of things. We started getting a lot more application security vulnerabilities once we built this process, a lot more than we were ever handing down at the time. We had, like I said, it was millions of lines of code and probably 300 major applications at one time that were running. A lot of times, instead of building a feature to distinguish between two clients, for example, there was like a fork made. and
Okay.
our client like an entirely like new code base. So it was a disaster in that regard, and so we had a lot of different things to scan.
Yeah, I still see that to this day, right? Walking into clients and they do something similar where they fork an entire, infrastructure and code base and then continue to make customizations. So
Yeah.
well, good. Yeah. Did we see anything pop up in Slack, Ken? I wasn't.
I do not see anything yet. No.
Okay. All right. Well,
Great.
good.
Thank you all.
Yeah. Thank you, Adam. Thanks for your time,
Thank you.
your expertise.
Yes, thank you.
Thanks, Adam.
Appreciate the support.